Alright, we're going to do Binomial Probability Advanced. What makes these a little bit more harder is instead of it just being that they're looking for the probability of 3 successes or 5 failures or whatever, they're going to put in stuff like more than, or at least, or less than, or at most, stuff like that. So we have to be a little careful in how we interpret these. First example. Suppose it is known that a new treatment is successful in curing muscular pain in 65% of cases. So because it's successful in 65% of cases, that chance of success, 65%, is the P. Okay. If it is tried on 10 patients, find the probability that 7 patients, find the probability that more than 7 patients are cured. So if it works on 7, that's not more than 7. So what we're really looking for when they say more than 7 patients is the probability of 8 or more cured out of 10. So to do that, to figure out the probability of 8 or more out of 10, we need to actually do some adding. We need to find the probability of 8 out of 10 plus the probability of 9 out of 10 occurring plus what's the probability of all 10 being cured. And if we figure those out and add them all together, we will have the probability of 8 or more being cured out of 10. So to do that, we use the formula which says n choose x times p to the x times q to the n minus x. So I'm going to start with 10 because we have 10 patients, so that amounts to 10 trials. And we're going to do choose 8 times p, which is 0.65, so times 0.65 to the 8th. And if we're successful with 8, we're unsuccessful with 2. So it's going to be times 0.35 to the 2. And we would calculate that. We would then do 10 choose 9. And we know when these guys differ by 1, when it's a 10 and a 9, this is going to come out to 10. So that's easy. But we're going to have 0.65 to the 9th and 0.35 to the 1, but we don't have to write a 1 up there. And lastly, we're going to have, it's not really necessary to write 10 to choose 10 because that's 1. There's only one way to choose 10 out of 10. And we're going to have that times 0.65 to the 10th. And I'm running out of room here. Let me scroll over a little. Times 0.35 to the 0. What's 0.35 to the 0? It is 1. So we don't really have to think about that either. Okay, now let's get rid of that. Oh, well, no, actually I'll leave it in. I'll get rid of it in the next step. 0.35 to the 0. So that's how we would fill it in. Now, the rest is pretty easy if you have a calculator. But for these parts, 10 choose 8. What does that come out to? You would have 10 times 9 times 8 factorial on the top divided by 2 factorial times 8 factorial on the bottom. The 8 factorials would cancel. The 2 would go into 10 5 times, and you'd be left with, that's not a 7, that's a 9, 45. So times 0.65 to the 8th times 0.35 to the 2. And then what's 10 choose 9? It's 10. Don't even have to do anything if we know our combo rules. And then we still have the 0.65 to the 9. So it'll be 10 times 0.65 to the 9th times 0.35. And then here, anything n choose n is the same as n choose 0. Either one, you get 1. So this is plus 1 times 0.65 to the 10th times 1, because 0.35 to the 0, anything to the 0 power is 1. So this would be our result. And you can just type that in your calculator and get your answer. I did this a moment ago in Alex, before I decided I didn't like that video and I got it right. But I'll do it again here so you can check your work. Sometimes I don't like this calculator. 0.65 to the 8th times 0.35 to the 2 plus 10 times 0.65 to the 9th, arrow over, times 0.35 plus 1, don't have to worry about those, 0.65 to the 10th. And it comes out 0.26160. So since Alex will ask us to round it to 4 decimal places, I'm going to put 0.2616, and that would be your answer. Let's do another one. Okay. This one says, also from Alex, a multiple choice exam consists of 7 questions with possible answers A, B, C, or D, and E. Let me check my time. Okay, we're okay for now. So 7 questions with 5 choices for each question. Find the probability that a student guesses at least 3 correct if she randomly guesses at each answer. So multiple guess test, and there's only 7 questions on it. There are 5 choices for each question. So what's the probability of guessing 1 right? It's 1 in 5, or 0.2, a 20% chance. How many trials do we have? We have 7 trials. And even though there's 5 possible outcomes, there's really only 2. It's reducible to binomial because you're either right or you're wrong. So P, your chance of being right is 0.8. Q, your chance of being wrong. P, your chance of being right is 0.2. Q, your chance of being wrong is 0.8. 80% chance of being wrong. So they want to know what's the probability that they get at least 3 correct. So to get at least 3 correct, you could get 3 correct, you could get 4 correct, you could get 5 correct, you could get 6 correct, you could get 7 correct. Well, that's a lot of things to calculate. 1, 2, 3, 4, 5. So you can save a little bit of time here if instead of calculating the probability of at least 3, you go and calculate the probability of not at least 3 and subtract it from 1. What do I mean? The probability of at least 3 correct is equal to 1 minus the probability of not at least 3. And how would we find the probability of not at least 3? Well, we'd look at 0 correct, we'd add to it 1 correct, and we'd add to it 2 correct. But we couldn't put anything higher than 2 because then we would be meeting the condition of at least 3. So if we figure out these 3 things, 0, 1, and 2 out of 7, and subtract it from 1, we'll have our answer.